Okay, so my components for my next 6502 project haven't arrived yet, so I guess we'll do another microcontrollers video. I was looking at, it was actually one of Bitlooney's, really, I mean, if you don't follow him on YouTube, he's fun to follow. But he had something where he was using these NeoPixel LEDs, and I thought that the samples that I've done so far for NeoPixels are pretty boring. I just basically test RGB, and I can draw to like, NeoPixel matrices like this one. I can draw text to them, for example. So I can draw lines and text, but my use of color in my samples so far has been a little bit limited. So I thought I'd explore that a little bit. And since I'm doing that, I might as well show you how you can actually get further than I got. So what I've got here is a sort of a continuous rainbow transitioning through the color wheel, which is handy if you're trying to do visual effects rather than having three channels like R, G, and B. You want a single value that you can go from 0 to, say, 255. That'll take you through this range of colors. So how do we do that? Well, the typical way is to use what's called hue, H-U-E. And you can have a continuous value going around the color wheel here. So this is an additive RGB color wheel. So red at the top, R, G down here at 120 degrees, and blue at 240 degrees. And these are the three video primary colors, right? Red, green, and blue. And then halfway between them are yellow, green, and magenta. Yellow, cyan, and magenta. And those are the secondary additive colors. So how do we run between them, right? Well, if you take a closer look, it's 25500 over here, and then 2552550 here for RGB. So in this first sector, you're basically just incrementing the G value, RGB. So G is going from 0 to 255. Then in the next 60-degree sector, from yellow to green, you're decreasing R from 255 to 0 and leaving the other two the same. In the next sector, from green to cyan, if you see you're going from 02550 to there, you're increasing the blue value, the blue channel, from 0 to 255 in nice continuous increments. So it's quite simple. Cyan to blue, decreasing the G channel from 255 to 0, blue to magenta, increasing the red from 0 to 255 again, and then magenta back to 0, decreasing blue from 255 down to 0. So it's not a hard algorithm to figure out. And I can actually demonstrate it. Let me load this up. I've got a program in my other window. So I'm going to stop this display and then show you how we step through it. And I'll show you how I did this in a second when I bring the other screen up. But let me show you the demo first. So I'm restarting, and we're starting at red. So we're at 0 degrees here right now. And now we're going to transition from red through to yellow. Actually, we might stop at orange. I'm going to stop in 30-degree increments where possible. So let's go there. So we're transitioning, and we're going all the way through to yellow. So now we're at yellow. So we went down the curve from there to there. And now we're going to carry on down into the greens. And we stopped at 90, which is the spring green. The colors on the video are not I'm seeing a much more springy green than what you're seeing through the video, which looks a little bit pale. And I've tried adjusting a bunch of things to try and improve it, but it doesn't really get much better. And let's go down to the next one. So we're transitioning, and we stopped at 120, which is a nice solid green. And then we carry on down the curve. We stopped at 180, which is looking more like a cyan in the video. In real life, it looks like a pretty good cyan. Video, it looks a little bit like a pale blue. Well, it is a pale blue. Carry on. We're carrying on around the curve. We're at 210, which is ocean blue. And then we're going to carry on again. around the curve, we're at really solid blue, and that does look blue in the video. Now we carry on to violet. We went past violet. We stopped at magenta. So now we're at magenta. And we carry on again. And we stopped at raspberry, which is sort of a pink. And then we're going to carry on again, and we're going to stop at 360, which is red. Okay, how did I do that? Let's have a look. That's the program I've been running. Let me switch that in better. And all I've done is I set a breakpoint as I'm running through. So I'm running in my color hues, I'm running from 0 to 256. And then I'm calculating the angle in the floating point value here by multiplying by 360 and dividing by 255. And mostly I get an exact value that's a multiple of 30, and I put a breakpoint there. So I've got an instruction here that does nothing, except if I don't have optimization on, then I can put a breakpoint here and it'll stop here. So if I was to restart this, reload it, and then, so F9 to put a breakpoint there, so there's a little red thing in the left there, and then just F5, and it stops on 0 on my breakpoint. And then if I run again, it's running, and you can see the angles clicking up here because I'm writing them out. And it stops again at 60 because 30 wasn't, you can see in here, it jumped straight from 29 to 31, so there was no 30. Anyway, that's how I was stepping through linearly in hues from 0 to 255 and then going around the wheel. Okay. I'm going to switch devices to, this one's quite nice in terms of the actual color values, but I've got some other devices as well, and I'll show you how I've made the program so that I can, so I've got 3 different devices that I'm looking at. So if we just turn the lights off on this one, I've got this one, which I've already showed you, which is a matrix from, is sort of an 8x4 matrix from Adafruit. And I've got another little one, which is a 5x5 matrix from Waveshare. And so how do we make NeoPixels work? So it depends on the board. So let's look at the Waveshare one. So the Waveshare, this one here, if I do that, and I rebuild, and then I'm going to plug in the Waveshare. I'm going to get rid of these lights because they're clogging up the area here. We probably won't see the NeoPixel, that Plasma one again. So yeah, before I get rid of it completely, I'll let you know what that was. So this is some arbitrary string of LED of NeoPixels, but I'm running it on a plasma board from Pimoroni, which is designed to run strings of NeoPixel LEDs. So it can provide quite a lot of power. So, and it's got a nice screw terminal on the side to just, it's basically designed, and it's on a 2350 CPU, one of the new ones. And this thing is basically just designed to run NeoPixel strings. So good board for that. But let's put that aside. So, and let's see what we have here. Obviously, I've already got it running on this little Waveshare matrix. So the Waveshare matrix got like 25 LEDs in it. So let's see how we switch the program. So I change the board to the Waveshare board. Inside the boards folder, every single board has a board definition file, and inside there it'll have it defined so that you can use that. So this one was Waveshare RP2040 matrix, right? So if I go and look at the program, scroll down to the bottom, I've got some fdefs here. So I've said if it's the matrix, if it's not the matrix, then do this. If it is the matrix, so for anything else, I'm going to do the Adafruit one, but for the Waveshare one, we do the Waveshare matrix. And if I right click on that, it'll jump to where it is. So there it is, Waveshare matrix. And because it's sort of hard coded here, you can't change the number of pixels or which pin it's on, any of that. So you can just use the built-in one. And the built-in NeoPixel initialization uses the values from the board definition. So how many pixels are there? In this case, 25. What's the pin that it's on? And then it just defaults to this as the RGB format for the pixels, which is the most common one. If it's not the correct one, then you'd have to sort of manually do it like this and choose the correct one. Like this one, for example, is RGB and not GRB. All right, you call that, you set the brightness, and these are super bright if you, I mean, like blindingly bright, or you can't look at them. It's like staring at the sun if you set them to the maximum brightness. So this is set to 10 out of 255, what you're looking at right now. Clear it, and then rainbow 5x5. So, and I've got this rainbow low thing as well. So let's go look at rainbow low. And it's sort of low, the low fidelity rainbow, it jumps the colors in bigger increments, and it makes it easy to see that there's multiple colors on the screen at the same time, rather than if you're looking at it like this, it looks like just one color, even though there's actually 5 at a time here. So let's do that. Let's run the optimizer. Let's build this. And what it's running right now is the previous program I loaded. So as soon as I upload it into the debugger, it'll stop on whatever color it was on. So it's stopped now. And then when I run, it'll start cycling through colors. There we go. And can you see this even? Yeah, it's very hard to see. But what we're seeing is a lot of different colors on the screen at the same time. So 25 different colors on the screen at the same time that it's cycling through. And that's sort of my low fidelity version of cycling through the hue. All right. Enough of this one. Let's switch to the next one. So I'll just unplug it and plug in the next one. And the Hopper environment, you know, it says serial lost. It immediately started running the program that was already on it. So let's switch back. And now I've switched boards to this Adafruit Feather. And on the Feather board, I've got 2 components. So I've just got any old feather on the left. And then the Featherwing is this matrix Featherwing. So because it's not the board, it's not specific to the board, it's not hard-coded, it means you have to configure it. So if we go and have a look at how that's configured, I just basically said, if it's not the Waveshare one and it's not the Pimoroni Plasma, then assume it's an Adafruit matrix. And then if we go and look at the Adafruit matrix, here we've had to manually configure it. And I've said there's 8x4. I could have used the length here because it is correct. Actually, no, I can't, because the board doesn't know that it's got, the board thinks it's only got 1 NeoPixel on it, because this board comes with a built-in NeoPixel. This little white thing over here. Yeah. So the board thinks it's only got 1 NeoPixel on it, and it thinks it's on a different pin. So if I go look at the board, it thinks it's got a NeoPixel on pin 21 and only one length of 1, right? Control backspace to jump back. Whereas I've plugged in something else into it, which is 8x4, and I know it's on, just from the spec I've looked up this thing, the data pin for the NeoPixel is GPIO 6. And I've set the brightness to 5 because this one's incredibly bright. 5 out of 255. In other words, really not very bright at all. And then we can build this. And are we still running Rainbow Low? I think we are. So let's see what happens. So we've built, load up this. It should stop it. Oh, it doesn't find the board. Why aren't you finding? Oh, because I plugged it into the power, not into the CPU. And I plugged it into the wrong USB cable. Okay. So if that happens to you, you can hit enter here to retry. And then it uploads it, successfully uploaded. Should have stopped that now. Yes, it's no longer moving. And now if I press F5, yes. So this looks like the lots of colors at the same time version. So you can see the whole rainbow sweeping through there. Let me do a larger version of that. So you can see the whole rainbow. I've got this reflector above it. It actually helps to make it look better. So there you can see the entire hue spectrum going through. And it's been done so that it'll show in, this is, 8x4. So what's this, 32 pixels. So it's jumping in increments so that it'll show you the whole range of the color wheel in 32 increments, right? So that's the sort of low res. That's why I call it Rainbow Low. So let's switch back. Control C to break out of the debugger. And you can, in this sample, I'll post the snippet for this sample and for the NeoPixel library at the time I made this video. It'll be in the description. So now if we switch from rainbow low to just the high-res rainbow, so what it'll do now in the 8x4 is it'll do each column as a color. So each column of 4 pixels is going to be a color, and it's going to be the full resolution. So it's going to slowly step through all 256 colors. And the effect of that is when it's on video, it looks like it's only one color on the screen at the same time. But I can try and show the enlarged version to show that it's actually showing shades. It's obvious to see the shades if it's transitioning from one obvious color to another, like from around the top of the, you'll see. Let's run it. So we load it up. Yeah, you see it looks like it's all red. Let's switch back to the full screen version. Yeah, so you can see a sort of trickle across there. If I turn it maybe slightly, you can see a difference in color. So maybe when it comes around to the top again, you'll see, yeah, you can see a wave going across of shades. Yeah, but it's actually cycling through all 256 hues. Anyway, this sort of effect is a lot more interesting than, let's do that. And I'm going to hit the reset button so we get some colors happening in the background. So if I reset it, it'll just keep running that program again in the background. Where's the reset button? There we go, reset button hit. So it'll just keep cycling those in the background while we talk. So how does this work? I added one API for this demonstration called setHue. Now, when I look this stuff up online, like how you would do and it's usually hue, saturation, and value, not just hue, and you do a HSR to RGB conversion. Usually they're doing it in degrees, and they're using floating point, or even at the very least they're using longs to do the, multiply by one big value and then divide by the denominator of what you want to get, multiply by 256 and divide by 360 or whatever it is you want to do to get the conversion. And this is tricky to do in Hopper at high speed because in Hopper, floating point values and 32-bit longs are reference types, not value types. They're not on the stack, so they can be quite slow. So what I did is I came up with an algorithm here to do it in integers. In fact, not even in integers, it's in bytes. So I divide the color wheel. So I've got 0 to 255 on my hues, and I divide it into 6 sectors. So what do we mean by sectors? Let's have a look at that. So 6 sectors, 1, 2, 3, 4, 5, 6. Around here, that's what they are, my 6 sectors. And so that's what the 6 sectors are. So divide by 43. If I divide by 42, it can overflow. If I divide by 43, then this value is going to be between 0 and 5, which means I can just have between 0 and 5 switch statements, one for each sector. And then I do the opposite for the remainder, which is the actual little increment in the sector. So I mod it with 43, and then I multiply that by 6 to get a value that's in the range of 0 to 255. And if you do the math, it's not actually 0 to 255. That range will be 0 to, I think, about 252 or something. But then, as I described in the beginning of the video, now you're just incrementing one of the channels. Like in this case, in the first sector, you're incrementing the G channel from 0 to 255. We're actually incrementing it from 0 to 252, but that's what remainder is there. And then these are the other six sectors, and that's how it works. So, and then I did performance optimizations and tests. Like I did a lookup table for this initially. Just to see, and the lookup table is slightly faster than doing the calculation and doing the switch statement, but not enough to care compared to the if I control tab to switch back to the other screen. This pixel show, NeoPixel show, takes much more time than setting the hues. So the incremental difference I got out of a lookup table wasn't worthwhile. I did this as a second function. It got a bit slower, you know, like having a function to do the calculation of hue to color and then taking those 3 RGB values and then calling set color. So slightly slower, it didn't seem worthwhile, and I didn't think I was going to use it for anything else. So I just added this one new API to the NeoPixel library. So this is the NeoPixel library I'm in. So I just added one more API to it. And the initial NeoPixel library, I got all these definitions from Adafruit's library, and a lot of these devices are from Adafruit as well. Like all this hardware is from Adafruit. You know, the doubler, the microcontroller, and the matrix. So, you know, support Adafruit. They put a lot of effort into figuring this stuff out and documenting it. And I just ported some of their work to my Hopper library. Just things like this table came from them. And then under the hood, the runtime for Hopper is built using the Arduino IDE. And in that runtime, I'm using their library as well, the Adafruit library. It's the de facto library for NeoPixels on microcontrollers. And then I also set this up so that you can use it as a display driver, so you can actually draw text on a bigger matrix. If you have a bigger matrix, you can do with the NeoPixel driver, you can draw text or lines or rectangles or whatever on the NeoPixel. But for this demo, I was interested in how you could make a interesting looking display with a continuous range of color, so you can just step from 0 to 255 in increments if you want to, and get a nice smooth continuous range of colors rather than just boring RGB or, you know, hacked versions of that. And I think that using set hue, you could come up with similar algorithms for doing other color ranges, not just the primary RGB additive color wheel. But this is a good one to get started on, and it's a good way to show you how to do it just with bytes. So these aren't even uints, they're just 8-bit bytes. The algorithm is implemented entirely just with 8-bit bytes. Yeah, sure, when it calls it, it might be using a uint for the hue. But there you go. I think that's enough about NeoPixels and making nice rainbows. Thank you for watching, and help other people find it by hitting the like button. And if you want to see more of this stuff and you want to see what I'm going to do with my 6502 when my bits and pieces arrive, you should subscribe. Cheers.